Hi, Geometry. This is Unit 3, Lesson 9, page 373 of our workbooks. So in this lesson, we're going to learn about one of the conditions for triangle similarity. It's angle side angle. It's not the same one as congruence. It's different, but we're going to be talking about that during this lesson. So let's take a look at these pictures. First, notice that we have triangle PQR. We have a smaller triangle P prime, R prime, Q prime. And I also have another smaller triangle SUT. So it says here triangle P prime, Q prime, R prime is congruent to triangle STU. So this is going back to Unit 2, and it said the triangle P prime, Q prime, R prime is congruent to triangle STU. Congruent means exactly the same size. All 6 parts, corresponding parts, are congruent. So let's take a look. Remember the ways that we could prove congruent. Back then we had 5 ways to prove congruent. It was side, 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 angle, side, angle, side, angle, 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 side, and HL. So looking at this little triangle and looking at this little triangle, I can see that I have multiple ways to prove that they're congruent. First of all, I know I have an angle and an angle, an angle and an angle, and this is the side in between them, and it's 1. So angle, side, angle, and angle, side, angle are congruent. So these guys could be congruent by angle, side, angle. Or notice they give me this side over here that's 1.5. And this is 1.5. So for the same reason, I could use side, angle, side, and side, angle, side. Oh my goodness, I actually see another one now too. If you use the angle, angle, and the 1.5, which isn't in between them, so angle, angle, and the 1.5, so really, this guy could also be angle, angle, side. I don't know 3 sides, so it can't be that one. It's not HL, so it's not that one. But any of those 3 work. So now let's talk about similarity. It says triangle PQR, this is my bigger triangle, is similar to triangle STU. That's my smaller triangle up above. We're going to make my bigger one then my original, and we're going to make the smaller one my image. We're going to see if the bigger one can be similar to the smaller one. So what I know about similarity is that I can do a translation, a rotation, reflection, whatever, and one dilation, and they line up on each other. So let's do that. Let me grab a piece of patty paper and let me trace this Q, P, I believe that was R, sorry about that, Q, R, P. And I know, because the angles are marked in such a way, that I could move Q to U or T, and I can move R to U or T. So I'm going to move R to U, R to U. Okay, great. Translate R to U. And I'm going to rotate until my sides line up like this. Now I have a nested triangle look. Then I'm going to dilate. I'm going to dilate and make my big triangle smaller. I'm going to shrink this side and bring it in and make it smaller. So 3 steps. I need to translate it in some way. It doesn't really matter. I picked R to U. Then I need to rotate about U until my sides line up. And then I need to shrink it, but with a dilation. So let's write that. So yes, these guys do look similar. I know that because I can translate, and I can translate lots of ways, you guys. I'm going to translate R to U, and then I'm going to rotate about U, and until what? Well, I don't know the angle measure in this case. I'm just going to say until sides line up. Sides line up. And then 3, I need to dilate. I need to dilate about U. That's the only point lining up right now. I need to dilate by U, about U, with scale factor. And now I need to figure out what my scale factor is. So looking back up at this, notice that this side right here is 3, and this side is 2. So when I move R to U and I rotate, I basically need this side that's 3 to become 1.5. Another way to look at it is I need this side over here that's 2 to shrink down and become 1. So I need my bigger triangle to shrink by a half. So if I think about my scale factor as being the image side over the original, it works whether I think about this as being UT over RQ, which would be 1 over 2, or I could think about it being US over RP, which is 1.5 over 3, which is still 1/2, or most of us would think about that as 0.5. So in order to get smaller, I would have to use a scale factor that's between 0 and 1. So then let's take a look at the second example. It's very similar. In the second example, though, I'm not given side measures, so I'm not going to be able to come up with a scale factor like this. I'm going to come up with a side ratio. So let's take a look. It says that my G prime, H prime, I prime is congruent to my M and O. So these two right here, are they congruent? Yes. When I look at them, I see angle, side, angle, congruent to this angle, this side, and this angle. So this is yes, by angle, side, angle. That's unit 2 work. And now it's asking me, is GHI, this is the bigger one, is it similar to MNO? This is the smaller one. So I'm going to make this my original, and I'm wondering if I can move it, dilate it, and get it on top of my smaller one. So let's take a look at that. So if I draw my big one on this sheet of paper, and this is my H, and it had 2 tick marks through it. This is my G, it had 1 tick mark through it, and that's my side. So if I move G to the angle it matches, which is M, so the angle it matches is M, I can see through my patty paper my 2 nested triangles. So I need to shrink my bigger one smaller. If I shrink my bigger one smaller, then all 3 of my sides would now line up. So I can say, yes, it's similar, and I'm going to translate first. So it looks like I translated, which you have 2 different ones you could do. I translated from the single tick mark to the single tick mark, but you could do H to N. It's the same thing, and you'd still have to dilate it smaller to get it to now line up. So I'm going to translate from G to M. That's just the way I picked. You could do the other one. And then I'm going to dilate. Now this is where our words would be different, because right now I'm at M. So I would dilate about M. That's my center. That's where I'm lined up with scale factor. So now remember, my image over my original. So in this case, you guys, I don't have any image sides. I'm not given any of these. So I'm just going to pick MN. I don't know what it is, but it's in my image. And then the side that goes with it is HG. That's in my original. I don't know what this is. Is it 1/3? Is it 1/4? Is it 2/5? I do know it's a ratio between 0 and 1, because this is smaller over a bigger number, but I don't know what it is. Could you use the other sides? Yes, you could use any of them. MO, sure, but it's over GI. And then NO, sure, but that's over HI. And can I flip the letters in any of these? Totally. Lots of possibilities that are all correct here. So let's flip to the next page that I want to talk about, which is page 375. 375, we're going to learn our first condition for similarity. So in this problem, we have 2 triangles. One triangle has a 60 and a 40-degree angle. I can see them. Let's mark the 60 different than the 40. I don't know why they do that. And let's mark the 80 different than the 40. We'll give it 3. So now this is where I need to remember that the angles add up to 180 degrees in a triangle. So I actually can find my third angle. Anytime you're given 2, it's easy to find the third one. So 180 minus 60 minus 40 tells me if I did 180 minus 60 minus 40, my other angle's 80 degrees. So this guy is an 80-degree angle. I'm going to mark it with 3 because that's what I did with my 80-degree angle. And down here on this one, this is 180 minus 80 minus 40, which would be 60 degrees. So this is 60 degrees. So these two triangles, they're at 3 angles match. And we say that they're similar. So this triangle, let's call this A, B, C, and let's call this triangle D, E, F. And we can say that these two triangles are similar, A, B, C, and triangle D, E, F. So notice I did line up corresponding angles. Notice I did not say EFD, for instance. I did match up my corresponding angles. So these are similar. In this case, they're similar by what we call the angle-angle similarity theorem or postulate. So this guy is going to be one of my 3 ways that I prove similarity. Why isn't it the AA? A. Why isn't it 3 A's? Well, the reason it doesn't need to be 3 A's is, as you can see, if I've got 40 and 80, I know my other angle is going to be 60. If I knew the 80 and the 60, I know my third angle is 40. I really only need 2 angles to be congruent in order to know that my 2 triangles are similar. So in this case, they're similar because they have 2 matching angles. Do they have 3 matching angles? Totally. So then that's the answer for number 1. And then it says, how long are the sides labeled X and Y? I'm going to use my proportions to solve this. And you've got lots of ways to set up your proportions, but you only have 1 correct answer for X and 1 correct answer for Y. So when I do this, I look and see which sides do I know both lengths. So when I look up here, X and 8 go together, the 6 and the Y go together, and the 3 and the 5 go together. So I'm going to be using 3 and 5 in my proportion. Which side do I know both? That's the 3 and the 5. So when I start my proportions, I'm either going to write 3 over 5 equals, or I could write 5 over 3 equals. It doesn't matter. It does not matter. However, once I write the 3 over 5 or the 5 over 3, now it matters. It matters a lot. So this is the little triangle side. Sorry, I'm trying to write in this blue. This is the little over the big. So when I write the other side, it better be the little triangle over the big triangle. This one was the big triangle over the little triangle side. So this one better be big over the little. So let's solve for X first. X and 8 go together. These two correspond. X is in the little triangle, so is the 3. X is going to be in my numerator with the 3. The 8 is in my big triangle with the 5. The 8 then will be in my denominator with the 5. And then over here, same thinking. 8 goes with the 5. The 8 will be in the numerator, and it corresponds to the side that's X. So now let's do our math. I'm going to use a pencil here. So now we cross multiply. So I distinctly get 5X and 24. Which one do I put on which side? It doesn't matter, you guys. It makes no difference at all. Just write the 24 on one side and write the 5X on the other. Divide both sides by 5. I'm going to go ahead and divide this one because I want to actually know how long the side is. I don't know about you, but I find it hard to think about how long 24 fifths is. So 24 divided by 5 is 4.8 units. Okay, great. If I solved this one, I'd still get 4.8 units because it's the same. Okay, in doing that, not to confuse you, but some students set up proportions differently. They think about the the 3 and the x both being, sorry, let me scooch this down for 1 second. They think about the 3 and the x being in the same triangle and the 5 and the 8 being in the same triangle. So they write, for example, 3 over x. That's fine. That's fine. This is in the little triangle. This is in the little triangle. Could you have wrote x over 3? Yes, totally. You could have wrote x over 3. However, since I wrote 3 over x over here, I need the same ratio from the big triangle. So I go back up here. Sorry, this other side had been in blue. So I go back up and I look and see that the side that's 3 goes with the 5 and the side that's x goes with the 8. So I'm going to put a 5 in the numerator because it's the side that corresponds to 3, and I'm going to put an 8 in the denominator. And you know what? When you cross multiply, you get 5x and you get 24. You still get 5x equals 24. You are still going to get 4.8. So not to be confusing, but there's about 6 different proportions you could write. But your answer every time for x will be 4.8. And so in one sense, this is not confusing because there's lots of ways that you can set up your proportion. But in other sense, it can be very confusing in the beginning because there's so many ways that you can set up your proportion. Let's take a look at finding y. We're just going to set this one up one way. So this was to find x. And down here, we're going to find y. So again, I look up at my problem. I know the 3 over the 5. I'm going to write 3 over 5. And then 3 is in the little triangle, and so is 6. And 5 is in the big triangle, and so is my y. So now when I cross multiply, I get 30 equals 3y. I divide both sides by 3, and 10 equals y. So I have my y and my x now. This was the angle-angle similarity theorem. When two triangles are similar by this, in this space in our book, let's write the following. Angle, angle, similarity theorem. This is if two angles of one triangle are congruent to two angles of another triangle. Sorry about, forgot my in there. Triangle. Then the triangles are similar. Awesome. So how do you see this? So flip in your books. The most popular way to the next page, which is 377, the most popular way we see the angle-angle similarity theorem is in the nested triangles. In nested triangles, not always, but a lot of times you use this in the nested triangles because of my parallel lines. For example, go ahead and mark a little tick mark here. Sometimes when I do my nested triangles, notice this is one angle that's congruent, and then angle A is in both the little triangle, the green little triangle, and the bigger triangle. So in this case, triangle A prime, B prime, C prime is similar to the bigger triangle ABC by the angle-angle similarity theorem. We're going to learn two other reasons, angle-side-angle similarity theorem and side-angle-side similarity theorem, but those are in the next lesson. So this lesson was about the angle-angle similarity theorem. I really should put the word similarity there. If you would do that for me, that'd be awesome. Okay, So let's look at your practice problems. I'd love to look at practice number 1. Practice number 1 is confusing because the triangles aren't sitting the same way. So some students need to redraw so the two triangles match. Well, what do you mean? There's the 44-degree angle and there's the 44-degree angle. So if I redraw this little one, putting the 44 on the bottom like that 44 is, and the 68 here, like it is in this one. So this is the little one. Notice that what I'm really doing, if I get my patty paper, if we grab our patty paper, this is the triangle. This is my 44, and it was B. This is my A, and it was 68. And this is my C, and I don't know what it is. So when I translate this guy over, so to my 44 lines up, and I reflect it, notice I didn't draw it the right size, but that means that my 44 is lined up with my bigger one's 44. My 68 is lined up with my bigger one's 68. It sits like this. So this is side A, this is side B, I'm sorry, this is angle A, angle B, and angle C, and AC is 6, and AB is 8. So what I really did is I basically rotated and flipped this triangle so it's sitting the same way as this one. This is a lot easier because DF is like my X. This is now a lot easier for students to see, does the 18 go with the 6 or the 8? It's kind of hard when you look this way, but now I can see that the 18 goes with the 6, and I can see the 8 goes with the X, and it helps me write my proportion better when they're sitting the same direction. So you can finish number 1. Let's take a look at number 5. Number 5 is similar to some problems we've done earlier lessons. You can set up scale factors between the sides, and it looks really, really, really good. The answer to this question is no, and it's going to throw some students off because the sides are in proportion. But think about what else we need to know for two shapes to be similar. We need something besides the sides being in proportion. There's 2 parts to similarity. Think about the missing part there. And then number 8. Number 8, to do number 8, part B, you need to remember the Pythagorean theorem first. So the Pythagorean theorem can only be used with right triangles, and it is that the longest side, c squared, is equal to a squared plus b squared, where c squared is the longest side. So in this problem, I would like to find x. And in order to do that, I need to first find the part A. It asks for me to find the scale. So in doing part A, if you look at your 2 triangles, you know something about one of the sides. So you can determine the scale factor. Keep in mind that Q is the scaled copy. So Q is the image, and R is the original. That will help you write in your scale factor for A. And then for B, in order to find X, you're going to use the Pythagorean theorem inside the little triangle. You actually don't really need the big triangle for that. Thank you.